So these are the contents of today's video session. So this picture clearly says the workflow that is especially happening during analysis phase. So as we have already discussed, there are 4 different phases in software development, namely inception, elaboration, construction and transition. The main concentration of the analysis phase starts in the later phase of inception and then in the earlier phase of this elaboration. So analysis brings towards the end of the inception phase and the main focus is during the elaboration phase. The main aim of this analysis workflow is to create something called as analysis model. So this model focuses on what the system has to be done, but it leaves about the implementation part, that is how it will be done. So this will be concentrated during the design workflow. So in the analysis workflow, the main target is to focus on what the system has to do. Next idea is to focus about the analysis artifact. So here is the definition of what is an artifact. Artifact is any tangible, that is any meaningful product or any byproduct which is produced during the development of a software. So during the development of the software, there will be multiple phases inside it. In each and every phase, if there is any meaningful, that is tangible output, then such particular output is classified as artifacts. So in analysis, that is after the analysis model has been completed, after the analysis phase is completed, there will be 2 different artifacts, that is 2 byproducts will be produced. One is called as analysis classes, which is the key model in the business domain. And next is called as use case realization. So this is used to illustrate how instances of analysis classes can interact to the end system behavior. So this slide focuses on analysis workflow. So here 3 personalities will be involving. One is called as architect, use case engineer and finally component engineer. So the idea of architect is to do with the architectural analysis, followed by use case engineer who will be analyzing the use case which is relevant to that particular system. And now the component engineer will do the actual class analysis and finally grouping the classes into packages. There are 8 different rules of thumb which has to be focused during this analysis modeling. The first rule says that the abstractions which are found during the analysis model should be apart from the vocabulary of the business domain. We cannot take anything outside from the business domain. It should concentrate only on the vocabulary. Each model must elucidate some important part of the system's desired behavior. We have to concentrate on capturing the big picture. So just concentrate on the overall system. Don't go for in-depth system analysis which can be done later. Distinguish clearly between problem domain and solution domain. 5th rule is that always try to minimize the coupling, and the other way is that you can maximize the cohesion. So coupling should be automatically minimized, that is association between the classes should be minimized, but cohesion means the association within the class that can be increased. Explore inheritance if there seems to be natural and compelling hierarchy of abstractions. So unnecessarily don't go for inheritance. Only if there is any situation for compelling the hierarchy of abstractions, you can go for inheritance. Never use inheritance only to reuse the code. Always ask if the model is useful to all the stakeholders. If it is not useful, then we can just totally avoid the particular model. Finally, you have to keep the model as simple as possible. So these are the 8 different rules of thumb which we are to focus while developing the analysis model. The third part of today's video session concentrates on classes and objects. So we have very well discussed about what is an object, what is a class, etc. So here are the formal definitions. So object is a discrete entity with a well-defined boundary that encapsulates state and behavior. It is also an instance of a class. So it is a cohesive packet of data and function together. But class is a common set of features such as attributes, operations or methods, etc. It is shared by a set of all instances of that particular class. So there are properties of classes and object. Identity are nothing but attributes. For example, if you take Samsung M30s, this is a class of mobile. But if you take each and every mobile phone, this 2 numbers are IMEI numbers, so which is used to uniquely identify a mobile phone. So that particular mobile phone is called as object. So any physical entity which is existing in this world is called as an object. A group of such objects are called as class. Next is called as state. State is determine the attributes, values of an object at a particular point of time. For example, the color of the mobile phone M30s may be a sapphire blue, and the memory is 64 GB, and then its battery power is 6000 mAh. So these are some of the state of an object at a particular interval of time. Next comes the behavior. Behavior are modeled as operations in analysis, and they are methods which is used to implement the design. Invoking an operation on an object will cause changes in the values of an attributes. So we have already discussed about the attributes. To change the values of these attributes, we are in need to invoke these operations. And this will be causing a state transition. For example, install app, it will change the battery power and also its memory capacity. Play game obviously changes the battery power. Next concept is messaging by objects. So in between two objects, we can say some information transition that is done by something called as messages. So such message transmission will lead to something called as collaboration. When object receives a message, what happens is that it looks a set of operations and checking for a matching signature. For example, imagine we have multiple methods like get, and then another method called as get with one argument inside it, another method called as get with two arguments inside it. So all these things are similar methods, but it have various signatures. So signature means it comprises of message name, parameter types, and also return value. So in this example, three messages are having same names but different method, that is parameter types. So what happens here is that any object, if it is receiving certain message request, then it will be checking for the matching signature. The corresponding matched operation will be automatically invoked. Now comes the core part of this video session. So here we'll be discussing about the UML object notation followed by class notation. So this is the representation of objects in UML. In UML, objects are represented using a rectangle icon with the two different compartments. One is going to say about the name of an object, which is represented as name, object name, followed by a colon symbol and then class name. So in this example, Jim's account is an object name and followed by class name, which comes under account. The next parameter, that is next compartment, is called as attribute compartment. So here we will be representing the attribute name, which is called as number, for example, followed by attribute type, which is an integer, equal to symbol, and then the initial value. So like which you can go for multiple attributes. And one of the major concentration here is that the name of the object in object notation should be always underlined. So this is used to differentiate between object notation and class notation. Some other notations. So the class name alone we can also have. For example, without an empty object name, we can simply start with colon and followed by the class name. But remember, it should be underlined. Or else we can go for object name alone without class name. So Jim's account can also be represented in the first compartment. And a combination of object name which is concatenated with the class name, which is separated by a colon symbol, which we have discussed in previous slide. So this colon has to be read as an instance of the class. So Jim's account is an instance of account class. That's how we are in need to read the object names. Naming object will be done by using something called as camel case. So camel case is an idea of mixing upper and lower cases together. This will be always starting with the lower case. That is the main concentration. So you can combine upper and lower case together, but initially we have to start with the lowercase letter. Special characters such as spaces, underscores may be avoided. As all the objects of the same class will have same set of operations, actually the list of operations is done during in the class icon. It is not represented in the object icon. Remember this. The next part of the presentation goes with UML class notation. Actually, class is represented by the rectangle icon, but with three compartments inside it. First one is called as a name compartment, second is attribute compartment, and third one is operation compartment. So in the class compartment, we go with the name of the class. So here, remember, there will be no underline symbol over here. So simply you will be represented by means of class name. This can also be added with something called as tagged values. So in previous class, we have discussed that these are the additional information which is going to represent along with something called as class name. The next compartment is called as attribute, where we will be listing the name of an attribute followed by the data type and some initial values. So here we can see some symbols like plus, hash, minus, etc. And we also can use something called as tilde symbol. These symbols are mainly used to say about the visibility adornment, which we can discuss later. And the last compartment is going to say about the operation, which we have something called as name of the operation followed by open and close parenthesis, and within that we can also pass arguments. Now we'll get into deep about each and every compartment. So first is name compartment. So actually the class name should be a camel case. The meaning of this is that it should begin with an uppercase letter and then it can have something called as a mixed upper and lowercase letter. So class name should always start with uppercase letter, but object name can start with lowercase letter. Special symbols such as punctuation marks, dashes, underscores, etc. should be avoided. Avoid using abbreviations also. So there is a difference between deposit account as a full term, and also this may also represent, but it will not be meaningful. So preferably use full names instead of abbreviations or short names. The next component is called as attribute compartment. So as the name says, here we will be discussing about or representing the attributes. So this will initially followed by the visibility symbol. So plus seems to say about public visibility, minus means private, hash is called as for protected, and tilde symbol is used to represent package visibility. And this will be followed by name of the attribute, which is mandatory. And then these are optional parameters where we can go with multiplicity. So what is meaning of multiplicity we can discuss later, and this will be followed by data type and then initial value. Multiplicity is used to represent the number of things which is participating in a relationship. You can see some examples here. For example, address is a string which composed of an array of 3 elements inside it. Name is a string component which is composed of either 2 or more number of strings. So that is a representation 2 ... followed by star. So star is going to represent any number. Next is an email. It is again a string representation which is composed of either 0 or 1. So either you cannot give any email ID or you can give one email ID. So more than that is not possible here. So such type of number of things component is represented using multiplicity adornment. Next is called a stereotype. So stereotype is used to extend the meaning of attributes by prefixing them with some certain stereotypes, which is used to indicate special meaning. For example, as I've already said you, to give additional information about the name of the class, we can go for certain attributes like address, which is added by Jim Arlo, and the date, like which some extra informations can be added. This is enclosed by using flower brackets. So that is a representation to denote stereotypes. The last compartment is called as operation compartment. So we'll be starting with visibility, followed by the name of the operation, and then parameter name, parameter type. So for each and every parameter, you are in need to give parameter name, colon, parameter type. Like for example, I colon integer, comma, S colon string, etc. And followed by 1 colon and then followed by the return type. Next focus is called as scope. There are 2 different scopes which can be represented in UML class diagram. One is called as class scope, other one is called as instance scope. So the meaning of class scope is that attributes that have single shared value for every object of the class, like static value which we use in Java. Operations executed by all the objects, not only by any particular instance. So any attribute or any operation which can be called and accessed by the complete set of instances is said to be class scope. Class scope features provide a set of global features for the entire classes of objects. The reverse of this is instance scope. So here the attributes and operations are accessible only by that instance alone. So by that object alone. So this is a representation of attributes and functions with instance scope and class scope. So anything which is underlined is said to be in class scope. For example, count is a variable which will be used by all the objects. So if I am accessing count using one object, and if I change the value as 1 here, obviously when the next object accesses the variable called as count, the value 1 can be accessed. Similarly, create is a function which is accessed by all the objects. Account number and the function called as get number, whichever is not underlined, are called as instance scope. So for each and every object, we have a separate copy of account number and get number, etc. So this slide focuses on the differences between attributes and operations which is declared by means of instance scope and class scope. So by default, attributes will have something called as instance scope. Similarly, attributes can upgrade it to something called as class scope. Similarly, operations by default we have instance scope which can be further upgraded to class scope. So every object in a class gets its own copy, but here the class is going to share the same single copy among multiple attributes. Each attribute may therefore have different instance scope attribute values, but here we have same class scope. Similarly, for operations, instance scope means we have separate copy for each and every object, but for class scope, a same copy will be applied, and the same memory space will be accessed by all the instances among the class. The last part of this video session is to represent about object construction and destruction. So for which we use constructors. They are special operations that create new instances of a class. So obviously this must be in a class scope. For every object we are in need to access the constructors. So a class may have multiple constructors. As you have learnt in previous object-oriented programming concept, it can have multiple constructors. Every constructor should have the same name which is similar to that of the class name. But the idea here is that it should have different parameter list. So this is called as constructor overloading. The constructor with no parameters is known as a default constructor that will be first called even if no parameters are passed through while creating objects. So this is how constructor is represented. So bank account is a class name and the function name is also bank account. So this says that this particular function is a constructor. The last part is called as destructor, which is automatically called in order to free out or deallocate the memory space. And the representation is a tilde symbol followed by class name and then parameter list. So parameter list is optional over here. That's all about today's video session. So in this session, we have discussed about analysis workflow and its artifacts, 8 rules of thumb, classes and objects and its properties, and UML notations for objects, and also classes with attributes, operations and its adornments. So the contents are referred from the book cited here. Thank you for your patient listening.